What if everything we thought we knew about the universe was just the tip of the iceberg? Imagine peering into a tiny patch of night sky and discovering not emptiness, but a breathtaking tapestry of hundreds of thousands of galaxies, each one a cosmic city, each one rewriting the story of creation itself. Thanks to the James Webb Space Telescope, we're witnessing the universe as no human has ever seen it before. The secrets it's revealing are not just changing astronomy, they're challenging our very sense of reality. If you're as fascinated by these cosmic revelations as we are, don't miss out on what comes next. Hit that subscribe button and join us as we continue to explore the mysteries of the universe, one discovery at a time. There's so much more to uncover, and you won't want to miss a single moment of this incredible journey. Subscribe now, and let's unlock the secrets of the cosmos together. Since the dawn of humanity, people have gazed up at the stars, wondering about the true size and nature of the universe that surrounds us. Every era has believed it was on the verge of understanding the cosmos, only to discover that the truth was far more complex and elusive than anyone had imagined. In its very first year of operation, the James Webb Space Telescope has accomplished something unprecedented. It has peeled back layers of the universe that were previously hidden from view, revealing cosmic phenomena that no other instrument has ever captured. With its powerful infrared vision, Webb has allowed us to peer into stellar nurseries where new stars are forming behind thick curtains of interstellar dust. It has shown us galaxies in the midst of slow-motion collisions, their shapes distorted as they interact and merge. In some of its deepest observations, Webb has revealed fields so densely packed with galaxies that our sense of scale is completely upended. But Webb's discoveries didn't stop there. It went even further, delivering a single image, a vast, intricate map of the cosmos so densely populated with galaxies and so rich in detail that it is forcing astronomers to reconsider how the universe developed in its earliest epochs. This image, known as the Cosmos Webb Field, stands as the most expansive and detailed map of the universe ever assembled. What it reveals is both astonishing and unsettling. The early universe was not a quiet, empty place waiting for structure to emerge. Instead, it was already teeming with activity and complexity. To appreciate why this new image is so transformative, it's important to recall how far we've come. For decades, our deepest look into the universe came from the Hubble Space Telescope. In 2004, Hubble focused on a tiny, seemingly empty patch of sky for more than 11 days straight. The results were shocking. What appeared to be a void was actually filled with about 10,000 galaxies, each containing billions of stars. Some of the light captured in that image had traveled for over 13 billion years before reaching Hubble's sensors. The Hubble Ultra Deep Field became an icon of modern astronomy, fundamentally changing our understanding of the observable universe and pushing estimates of the number of galaxies into the trillions. Yet, Hubble had its limitations. It primarily observed the universe in visible light, and as we look further back in time, the expansion of the universe stretches that light into the infrared, a range Hubble could barely detect. This is where the James Webb Space Telescope comes into play. With its enormous golden mirror and advanced infrared capabilities, Webb doesn't just look deeper into space, it looks through cosmic dust, through the epochs of time, and into eras that were once completely hidden from view. When Webb began its observations, it didn't simply refine the picture painted by Hubble, it completely transformed it, revealing a universe far more dynamic and complex than we had ever imagined. To truly grasp the magnitude of Webb's leap forward, imagine this. If the Hubble Ultra Deep Field were printed on a single sheet of paper, the new Cosmos Webb image, at the same level of detail, would stretch across a wall more than 13 feet wide. This isn't just a close-up snapshot, it's a sweeping, continuous map of the universe. Unlike Hubble's Deep Field, which was a narrow gaze into a small region of darkness, Webb's survey covers an area of the sky about 3 times larger than the full moon as seen from Earth. Creating this cosmic panorama required over 250 hours of observation, with thousands of individual exposures meticulously combined into one seamless tapestry. The result is nothing short of breathtaking, more than 780,000 galaxies, all visible in a single frame. This map is not just a collection of distant objects, it's a record of nearly the entire history of the universe, stretching from a few 100 million years after the Big Bang all the way to the present day. For the first time, astronomers can trace the evolution of galaxies across cosmic time without having to piece together disconnected images. It's like the difference between looking at a single street and seeing an entire city, complete with its neighborhoods, suburbs, and the roads that link them all together. But the surprises don't end there. What we're seeing isn't a flat, static image. We're looking through layers of time itself. The galaxies closest to us appear as they were billions of years ago, already mature and often engaged in gravitational dances with their neighbors. Across this vast field, galaxies are not scattered randomly, they cluster together along invisible threads, forming the immense cosmic web that shapes the structure of the universe on the largest scales. Within this same map, astronomers have stumbled upon something truly remarkable. They discovered a pair of galaxies in the midst of a collision, forming a shape so distinctive that it has been nicknamed the Infinity Galaxy. These two galaxies are entwined in a slow, dramatic encounter, and between them, something unexpected seems to be taking shape, a supermassive black hole, not at the center of either galaxy, but in the space between them. If this finding is confirmed, it could point to a previously unknown pathway for the formation of black holes, suggesting that these cosmic giants might sometimes emerge in the turbulent regions where galaxies collide, rather than only at their centers. This discovery is a powerful reminder that when we observe enough of the universe at once, rare and fleeting events finally come into view. This is precisely what the Cosmos Webb project was designed to achieve, to reveal the extraordinary by capturing the universe in unprecedented detail and scale. As we delve deeper into this image, we are not just looking further into space, we are traveling back in time, uncovering the story of how the universe built itself, one galaxy at a time. As we journey further into the depths of the Cosmos Webb image, we find ourselves approaching an era astronomers call cosmic noon. This was a period about 10 billion years ago, when the universe was at the height of its star-forming activity. Galaxies during this time were ablaze with the light of countless newborn stars, fueled by immense clouds of gas. Yet even in this era of cosmic exuberance, the James Webb Space Telescope has uncovered mysteries that challenge our expectations. Some galaxies appear to have already run out of fuel, their star formation quenched and their structures quiet and dormant, long before our models suggest this should have happened. Others, surprisingly, display elegant spiral arms and well-ordered shapes, even though they existed just a few billion years after the Big Bang. According to the prevailing theories, galaxies in the early universe should have been chaotic and disorganized for much longer. The forces of gravity, turbulence, and frequent mergers were expected to keep things messy, preventing the formation of the graceful structures we see in more mature galaxies today. But the universe, as revealed by Webb, seems to have taken a different path. Processes that were thought to require billions of years appear to have unfolded in a cosmic instant. The pace of evolution, it turns out, was much faster than anyone had anticipated. This rapid development becomes even more dramatic as we push our gaze further back in time. We approach the edge of what was once thought possible to observe the cosmic dawn. This is the epoch just a few 100 million years after the Big Bang, when the very first galaxies were expected to flicker into existence as faint, fragile structures. Before Webb, astronomers believed that bright, well-formed galaxies at such distances would be exceedingly rare. But once again, the telescope has upended expectations. Webb has found these luminous, massive galaxies in surprising numbers, shattering previous records for the most distant galaxies ever observed. Take, for example, galaxies like JWST, which Webb captured as it existed just 290 million years after the universe began. Even more recently, another galaxy known as MOM Z14 was observed shining brightly only 280 million years after the Big Bang. These are not dim, primitive objects. They are already massive, chemically evolved, and filled with elements like carbon and nitrogen. This means that earlier generations of stars must have formed, lived, and died in an almost impossibly short span of time, enriching these galaxies with heavier elements. In cosmic terms, the universe seems to have grown up astonishingly fast, much faster than our current models can comfortably explain. The discoveries made by Webb are forcing astronomers to reconsider the timeline of cosmic evolution. The early universe appears to have been more crowded, more structured, and more mature than anyone had predicted. Galaxy formation may have started earlier, and black holes may have grown faster than previously thought. Entire mechanisms that we have yet to imagine could be at work, shaping the cosmos in ways we are only beginning to understand. This is why the Cosmos Webb image is so significant. It doesn't just present us with a collection of extraordinary objects, it compels us to face a fundamental challenge in our understanding of the universe. The early cosmos, as revealed by Webb, is far more crowded, organized, and mature than our best theories had predicted. The processes that shape galaxies and black holes may have started much earlier and progressed much faster than we ever imagined. The very mechanisms that drive cosmic evolution might be more complex, or even entirely different from what we have long assumed. As a result, astronomers are now re-examining the foundations of their models, not because Webb has failed to provide answers, but because it has succeeded so spectacularly in revealing new questions. This is the hallmark of a true scientific revolution. When a single observation or discovery opens up more mysteries than it resolves, it signals a turning point in our quest for knowledge. The Cosmos Webb image is exactly that kind of breakthrough. It has forced scientists to return to the drawing board, to rethink the timelines and processes that have shaped the universe from its earliest moments. The early universe, once thought to be a quiet, empty stage waiting for the first galaxies to appear, now looks more like a bustling, chaotic workshop filled with activity and creativity from the very beginning. What does this mean for our understanding of the universe's true scale? The answer is both humbling and exhilarating. The scale of the cosmos, as revealed by Webb, is not just measured in light years or the number of galaxies. It is measured in the realization that even a tiny patch of sky can contain hundreds of thousands of galaxies, each one a vast island of stars, gas, and dust. The early universe was not a slow, gentle unfolding of structure, but a rapid, energetic explosion of creativity. Our most confident timelines for how galaxies and black holes form now seem like rough sketches in need of major revision. We are living in a remarkable era. For the first time, humanity is able to see the universe with unprecedented clarity. The Cosmos Webb image is the largest and most detailed map of the universe ever created, yet it is still just a single window into the vastness beyond. There are countless more regions of the sky waiting to be explored, each one potentially filled with its own surprises and mysteries. The universe is larger, richer, and stranger than we ever dared to imagine. And thanks to the James Webb Space Telescope, we are finally beginning to see it as it truly is. This new perspective is both a triumph and a challenge. It reminds us that science is a journey, not a destination. Every answer leads to new questions, and every discovery opens up new frontiers. The Cosmos Webb image is not the end of our search for understanding. It is the beginning of a new chapter in our exploration of the cosmos. The revelations from the James Webb Space Telescope have not only expanded our view of the universe, but have also transformed the way we think about cosmic history. Each new discovery from Webb is like turning a page in a book we thought we knew, only to find the story is far more intricate and surprising than we ever expected. The Cosmos Webb image, with its staggering number of galaxies and its reach across nearly the entire history of the universe, is a testament to how much more there is to learn. It's not just about seeing farther, it's about seeing differently, through dust, through time, and through the very fabric of cosmic evolution. One of the most profound aspects of Webb's findings is the realization that the universe's early years were anything but simple. Instead of a slow, gradual emergence of structure, we see evidence of rapid growth and complexity. Galaxies that should have been in their infancy already show signs of maturity. Black holes, which were once thought to take billions of years to form and grow, appear to have reached enormous sizes in a fraction of that time. The presence of heavy elements in these early galaxies suggests that multiple generations of stars lived and died in quick succession, enriching their surroundings with the building blocks for planets and eventually life. This accelerated timeline challenges many of the assumptions that have guided cosmology for decades. Theories about how galaxies assemble, how stars are born and die, and how black holes come into being are all being re-examined in light of Webb's data. Some scientists are even proposing entirely new mechanisms to explain the rapid pace of evolution seen in the early universe. Perhaps there are processes at work that we have yet to discover, hidden forces or interactions that shape the cosmos in ways we are only beginning to comprehend. The impact of these discoveries extends beyond the realm of professional astronomers. For anyone who has ever looked up at the night sky and wondered about their place in the universe, Webb's images offer a new sense of perspective. They remind us that the universe is not a static backdrop, but a living, changing entity. The galaxies we see today are the result of countless cosmic events, collisions, mergers, explosions, and the relentless pull of gravity playing out over billions of years. Each point of light in the Cosmos Webb image is a chapter in this ongoing story, a reminder that the universe is always in motion, always evolving. As we continue to analyze the data from Webb, new questions arise. How did galaxies become so organized so quickly? What role did dark matter and dark energy play in shaping the early universe? Are there entirely new types of objects or phenomena waiting to be discovered in the depths of space? The answers to these questions will not only reshape our understanding of the cosmos, but may also reveal new insights about the origins of our own galaxy, our solar system, and even life itself. The journey that the James Webb Space Telescope has set us on is only just beginning. Each new image, each new data set, is a reminder that the universe is far more vast and mysterious than we ever dared to believe. The Cosmos Webb image, as breathtaking as it is, represents just a single window into the endless expanse of space. Beyond its borders lie countless more galaxies, nebulae, and cosmic phenomena waiting to be discovered. The realization that even a tiny patch of sky can contain hundreds of thousands of galaxies is both humbling and exhilarating. It forces us to confront the true scale of the cosmos, not just in terms of distance or number, but in the sheer depth of its history and the richness of its structure. For the first time, we are able to see the universe not as a static snapshot, but as a living, evolving entity. The galaxies captured by Webb are not frozen in time. They are part of a dynamic story that stretches back to the very beginning of everything we know. Each one is a testament to the creative forces that have shaped the cosmos, from the first bursts of star formation to the complex interactions that give rise to new structures. The early universe, once thought to be a quiet and empty place, now appears as a bustling workshop filled with the raw materials and energy needed to build the galaxies, stars, and planets we see today. This new perspective is changing not only our scientific understanding, but also our sense of wonder. The more we learn, the more we realize how much remains unknown. The questions raised by Webb's discoveries are profound. How did the universe organize itself so quickly? What unknown processes might be at work in the formation of galaxies and black holes? Could there be entirely new forms of matter or energy influencing the evolution of the cosmos? Each answer seems to open up new mysteries, inviting us to look deeper and think more creatively about the nature of reality. The impact of these discoveries goes beyond the realm of astronomy. They touch on some of the most fundamental questions humans have ever asked. Where did we come from? How did the universe begin? Are we alone in this vast expanse? The answers may not come quickly, but the journey itself is a testament to human curiosity and ingenuity. With every new observation, we are reminded that science is not just about collecting facts, but about expanding the boundaries of what is possible to know. As we look to the future, the James Webb Space Telescope stands as a symbol of our desire to explore, to understand, and to marvel at the universe. Its images are not just scientific data. They are invitations to wonder, to question, and to dream. The universe is larger, more complex, and more beautiful than we ever imagined. And for the first time, we are beginning to see it with new eyes, opening the door to discoveries that will inspire generations to come.